Hey guys, so today we're going to be on lesson 72, and that is talking about graphing inequalities. If you guys have your textbooks with you, you can follow along with me and see the exact same examples that I'm going to put on the screen here. Yeah, it is going to be lesson 72, like I just said, and it is going to be on pages 228 and 229. But with lesson 72, it starts by reviewing all the way back to lesson 2 and probably before that for some of us about how the number line, like we see right here, it helps to give us a visual of why certain numbers are larger or bigger than other numbers. We obviously can see here that 5, I'll draw a marker, hopefully we can all see it here. We know that the number 5 is a larger number than the number 2, for example, because the number 5 over here is further to the right. I'll just draw us an arrow here so we can have some kind of helpful visual, because 5 is further to the right than 2 is. So 5 therefore would be a larger number than the number 2. Now on the negative side, this is where it kind of can confuse some people, but as long as we can remember the number line, then we know that we'll be okay. Because we can say that negative 2 is a larger number than negative 5. If we don't look at the number line, then we might think without actually looking at it that negative 5 is larger than negative 2, but that's just not the case because negative 2 in this instance is further to the right than negative 5. So negative 2 therefore would be the larger number between negative 5 and negative 2. In this lesson, they're introducing a new symbol. For some of us it might be new, and for some of us we might have seen it before, which is going to be the greater than or less than symbol. So I'll just draw a 1 so we can see it here in the middle. We'll say greater than. Now these symbols, this little corner shape here, is read from left to right. We read this from left to right. So if we put negative 2 is greater than negative 5, we would read this equation from left to right just like we read regular words inside of a book or a page. So negative 2 is greater than negative 5. And in this case, this situation would be true because negative 2 is greater than negative 5 because it is further right on the number line. Now I'll clear our little whiteboard here out so we can see a little better. And we'll go forward here just a little bit more. Likewise, just with the greater than symbol, it is a greater than or less than symbol because we can flip it and read it the opposite direction. Again, we read from left to right and we get to the smaller side first to the larger side, so we would read it less than. So we would put negative 5 is less than negative 2. And in this instance, again, this would be a true equation because we see that negative 5 is, in fact, less than negative 2 because negative 5 is further left on the number line than negative 2. Now, we're going to go into this a little bit later in the lesson, but if you guys are following along in your textbooks, you'll see at the bottom of page 228 that it introduces the greater than or less than or greater than and equal to symbol. So we have our greater than symbol and we have our less than symbol. And if we add half of an equal sign below the greater than or equal sign, then this becomes greater than or equal to a number or less than or equal to a number. So the example in the book that we see here is that negative 4 is greater than or equal to negative 12. Now we're going to go into this, as I said, a little bit later, but just so we can understand how to read this equation is why it's showing us in the book right now. We would read this from left to right, and we would go negative 4 is greater than or equal to negative 12. And if we flipped the symbol around, we would read it the opposite way, still going left to right. Negative 12 is less than or equal to negative 4. Again, like I just mentioned, we are going to go into that in just a little bit, but since the book does introduce it right there, I wanted to go ahead and mention it so nobody was getting lost as we are following along. Now on page 229, it talks about an equation about what it has to do or what it has to have. And an equation basically states that two quantities are equal. So if we have, for example, I'll write one on the board or on the page here just for simplicity. If we have 2 plus 2 equals 4. We all know that 2 plus 2 equals 4, so everybody give yourselves a round of applause. But 2 plus 2 is 4. 4 equals 4. We're just condensing these down. So this would be a true equation. This is true because 4 does in fact equal 4. Now, this is typically how equations are. For true equations, it's one side is going to be equal to the other side. Now, then there is statements of inequality, where one side is not going to equal the other side, or the equation itself is false. So 2 plus 2 equals 7. Well, 2 plus 2 is 4. 4 equals 7. This is in fact a false statement. I'll just write F over here for false. So we see that in fact 4 equals 7. 4 does not in fact equal 7. So we'll go ahead and cross that out so that it is not a true statement. And then let's see, get these cleaned here off. Then we have a third type that it could be a conditional statement. And that would be in the case of if we had x is greater than 2. I'll write C over here for conditional. This statement, as it's written right here, and sometimes as it's written in our textbooks, we can't tell just by looking at it whether this is a true or a false statement. Whether this is a statement of equal or a statement of equal factors or a statement of inequality. Because if x is anything larger than 2, we'll go ahead and mark it on our number line just so we can see here. We have 2 right here. If x is anything to the right of 2 on the number line, then this statement becomes true. But if x is anything to the left of 2 on the number line or lower than 2, then this statement becomes false. So we just see that as this statement is written right here, x is greater than 2, this statement would be called a conditional statement because it's all dependent and conditional on what number we plug in for x. So going forward with that, we'll clear this off so we can have an empty spot. Let's see. On page 229, if you have your textbook, where it says example 72.1, this is going to be example 1. It says graph, and I'm going to write it here so we can see it. Graph x is greater than 2. I guess I could have left that on the board, but it won't hurt us to write it again. So it says graph x is greater than 2. Meaning when it says graph and then it gives you that equation, it's meaning to graph it or write it on a number line. So on your homework or on your page, you would actually draw a number line similar to this, and you would actually graph these points. So how we do this is, I'll turn this off so it doesn't fill in, is that we would start, so we know that x, the condition here, when it says graph, it's going to be graphing this on a number line so that it's a true statement. So x is greater than 2 means that all the options, all the possibilities for x are going to be all the numbers that are larger than 2. So x is greater than 2. We're going to draw a circle around the number 2 marker on our number line. And then we would draw a line to the right because this is, remember, this is going to be all numbers greater than 2. And then we would draw an arrow at the end. This symbolizes that all of the possibilities for a true statement are going to be all the numbers that are to the right of the positive number 2. Now, one more example that we might run into is if we have on example 72.2, so example 2, about halfway down the page on 229, it says graph x is less than or equals to 2. X is less than or equals to the number 2. So to graph this on our page, we would go to our number 2 spot, because for this to be true, it's going to be all the numbers to the left of the number 2 because it's less than, but since it's equals, less than or equals to, we're also going to include the number 2 itself. So this time, since it's less than or equals to, we're going to shade in or fill in around the number 2 spot and draw an arrow to the left, which symbolizes that all of the true possibilities for this equation, x is less than or equal to 2, include all of the numbers from 2 to the left, including 2 itself, because in this case, it could be 2. It could be equals to 2. So just one final point before we go ahead and end this video. If we have an equation that is less than 1, all of the possible answers are all the numbers to the left of 1, but it could not be 1 itself because it's not less than or equals to 1. So we would draw a circle around 1 and do all of the numbers to the left. If our equation is x is greater than or equal to 3, it's going to be all of the numbers to the right of 3, including, it could be 3 itself, because it's greater than or equals to 3.